So in this course in particular, see, remember the IPL match will generate a lot of data, and already I've told you there are 816 matches, so that's into 2, maybe 1600 odd innings, because some of them will get rained out and all that, second innings may not happen. So you will have about 1600 innings data, and each innings is 20 overs, it's at least 120 deliveries, in fact usually 125, 126 deliveries, and then so many runs scored, so many different type of batsmen. So you have to really make a choice as to what you are interested in, and then focus on that and study that. You can be interested in so many things, but in this course, I thought what's interesting to study is the power play overs. Okay, so I wanted some amount of data which is voluminous enough, big enough that you cannot quickly make all the patterns that you can study. You cannot quickly finish it off. At the same time, you can never quite accurately fully model. It should be complex enough that it's going to be random every time something happens, right? So I wanted something rich enough, and at the same time not so voluminous that everybody is thrown off by it, right? So this seemed like a good choice to make. The IPL power play over. So what's the power play? The power play in IPL is the first 6 overs, and there is a restriction why it's called a power play. There can be only 2 fielders outside the inner circle on the boundaries, so a lot of runs get scored in the power play. So it's an interesting time, and it's also a predictable time, right? So there's no wickets when they start off. All teams are sort of starting with the same roughly same initial condition. Of course, they may lose wickets as they go along, but roughly same initial conditions. The first 6 overs I thought were a nice thing for us to expect some patterns in, right? So maybe there are some patterns there. Okay, so once you know what is the focus area of your problem that you're interested in, you can go ahead and collect the data. So you run a Python script which will collect the data from the first 6 overs of the power play period in an IPL innings, and every IPL innings, the first innings, second innings, and then start. Before you even do any serious answering of questions or building of models, you have to sort of play around with the data. See if you can put it in a spreadsheet, calculate some numbers, draw some pictures, see if you can do something, and just get comfortable with what kind of things you're seeing. So that is something which is usually the second step. So we may not do too much of all that in this course. You may do it in your later courses, but let's see how it's done. This is just the first, in fact, it's the 0th week of the course, so we can do whatever we want. So let's just look at how this data works out. Okay, so this is a sample from the data. Like I said, I've written a script which takes the data from the YAML files and puts it into a spreadsheet. This is a Google sheet. I will share the link of the sheet with you, so you don't have to do the Python script work and all that. The entire spreadsheet itself will be given to you. Here is a sample of this, and let me click on the spreadsheet. This will take me to the actual sheet. Okay, this is the, let me open it with Google Sheets. Okay, see, there you go. So that's the data, and this is a sheet that I have shared with. So if you see shared with, it is shared with IIT Madras. So anyone in this group can click on this link to view. Okay, so this link will be given to you. So the sheets link will be given to you. So you can just click, as long as you're logged in with your online degree ID, you can click on this link and this sheet will be accessible to you. You could, I don't know if I want to say that you should not share it with anybody else, but no, you could share it with others too if you think other people are interested in this. But this is just a sheet. It's information that I took from elsewhere, so it's okay for you to keep it. Okay, so this is you will have viewing permission. I don't think you will have writing permission. So this sheet is what we have. Okay, so let's just look at this data. Okay, so just to get ourselves familiar with what kind of data we are looking at. So you can see the data I have pulled. You have to pull this data from the YAML file. What I've pulled is the date of the match. I've pulled the venue of the match. Okay, so those of you who know cricket, Chinnaswamy Stadium is in Bangalore. It's a very small ground, so lots of runs typically get scored there. The Mohali Stadium is also a good batting pitch, etc., etc. Wankhede, for instance, or Eden Gardens is a bit more supportive to the bowlers, and things like that. So the venue is quite important in a cricket match. Okay, so the innings, first and second innings, you will go first innings, second innings, first innings, second innings. For the first innings, there is no target set, For the second innings, there is a target. So for some reason, I wanted to put the target in there because the target can influence how runs are scored in the power play period, right? So you may have teams try to chase down a large target, make use of the power play. So maybe there is some correlation here. We'll see. Those are patterns you can think of later. But this is interesting data to keep in mind. And then, of course, the team that did the batting, and then how many runs were scored in each ball. So I've not included extras or all those information. I simply take the total runs that were scored in each delivery. Okay. Now normally every over should have 6 deliveries, but of course if there was an extra, there would be a 7th delivery, 8th delivery, etc. As it turns out, in the matches I've considered in IPL, the maximum number of deliveries in a single over was 10. But I just kept it up to 12 just for gap. So you see the 11th and 12th delivery never came up in an over, but up to 9 or 10 you will see some overs go. Okay, so maybe it's surprising or not surprising to see that in the first over, quite a few first overs seem to have 7 deliveries. Okay, so it's not surprising, right? If you think of how the first over goes, the bowler himself is loosening up, etc. So it's very likely that there is at least a wide, somewhere it would come from. Okay, so that's the first over. Okay, so my spreadsheet now, hopefully you get a feel for how my spreadsheet is going to go. Every row corresponds to an innings from an IPL match. Every column is different things. Okay, so you saw venue, innings, target, team, and then what happened, how many runs were scored in each ball. And then at the end of the first over, I've put here 3 summary information. One is D1. D1 is how many deliveries were there in the first over. Okay, so you see 7 deliveries because there was one wide or a disallowed delivery. And then how many runs were scored in the first over, that is this R1. Is that okay? Hopefully you see that. So there were 3 runs that were scored in the first over, and how many wickets fell in the first over. Okay, so I've collected this D1, R1 and W1, which is how many deliveries were there in the first over, how many runs were scored in the first over, total runs, and how many wickets fell in the first over. Okay, so this is what I've done. Now I'll repeat this for every other over in that innings. I mean, as in every over in the power play part of that innings. Okay, so you can see in the second over here, it's been a lot of scoring, right? So 4, 4, 6, 4, 0. I think this is the very first IPL match back all the way in 2008 between Bangalore and Kolkata, if I'm not wrong. I think this was Brendan McCullum hitting all those 4s and 6s. Okay, so that's what happened in the second over. And in the second over, you can see there are 6 deliveries, 18 runs, and no wickets. Okay, so like that, for every other match, you will have this information. So this will go all the way up to third over, fourth over, fifth over, sixth over. Okay, so in the sixth over, it stops because I'm not interested in anything beyond the power play. So this is how this is what I've looked at. Is that okay? Okay, hopefully this gives you a sense of what this data is, and I mean, at this point, maybe you're a little worried about how the spreadsheet came from all those files and whether you'll be able to do that, etc. It turns out Python is a wonderful language. It has so many powerful modules, and you don't have to write really a long program to do it. The script that I wrote hardly had some 10 or 15 lines. Okay, so that's it. Just with 10 or 15 lines of code, and running it takes some time to run. Once it runs, you get a sheet like this. Okay, so it's not too difficult to do something like this. Okay, all right. So that's the spreadsheet. Now, once you have spreadsheet like this, I don't know how much you've fooled around with spreadsheets and getting making calculating descriptive statistics with spreadsheet. Particularly Google Sheet is quite easy to use because of this explore option. I like this a lot. You don't have to type out know the formulae for something ahead of time, etc., etc. So you can you can ask a lot of questions to it, and what reasonably phrased questions, and it will come up with something of its own. So for instance, I might want to know average of R1, right? So R1, if you remember, it's the number of runs scored in the first over. It's a 6, right? So across all these matches that were there, by the way, there were I think about 1,600 innings data is there in this file. Okay, so it's quite a big spreadsheet in some sense. So you may want to see, like for instance, maybe average of R1 by team. Okay. So you see here it shows a little pivot table with by team how many what is the average of R1 Chennai Super Kings. You know, they're always slow starters. So you see 5 runs per over, and then you see, I don't know how many of you remember the Kochi Tuskers. They played in 1 year, Gujarat Lions. Maybe that's not so interesting. So anyway, so you can do things like this. So you can do comparisons. You can very easily do so many other things you can ask here. So I don't know if you're comfortable with how comfortable you are with histograms. You can do histograms here. If you do histogram of R6, it will show a picture like this of how many innings you had this kind of range of runs, right? So the runs are only integer. So if it says 15.26 to 16.15, the 16 runs were scored. The highest runs you can see it's somewhere here, one match or so. There were 3 matches in which 25 runs were scored in the first over, and you can see this is the distribution. Okay, very few matches in which like 0 runs were scored, and then the maximum number of matches is like around 6 runs is where you have a lot of matches, and then it tapers down a bit more slowly, then it rose up. It rose up quite fast, and then it has a longer tail, right? So that's the sort of distribution that it has. You can do so many other things. You can do, like for instance, I'll just show you a scatter plot of R1 versus R2. You can try this. This will plot R1 versus R2, right? So you can see how that looked for a particular R1. So supposing 10 runs were scored in the first over, how many runs were scored in the second over, right? So things like that. Do you expect a pattern here? I don't know. I mean, so you can see these kind of things. Maybe you want to see something like this: scatter plot of R6 versus W5. Like, okay, this might be interesting, right? How many runs were scored in the 6th over versus how many wickets fell in the 5th over? Okay, so let's see that. Does that is that going to produce some pattern here? You can see, yeah, you can see the pattern, right? So if 0 wickets fell in the 5th over, you can see this, the number of runs scored in the 6th over goes all the way up to 21. 1 wicket, this, except for this exceptional case, it has really reduced. And if 2 wickets fell in the 5th over, it really reduces. The maximum is just 16, and then it has gone down. Okay, so you should do things like this, and I would strongly suggest it. Even for moderately big size data like this, you should pull it up into a spreadsheet and explore these kind of questions. And Google spreadsheet, all of you have access to your G Suite account. You can open Google spreadsheets and ask all these questions. There are so many more things you can do. I'm just showing you some of them. Okay, so let me go back to this slides and then show you some of the things that I fooled around with in that explore box there, and then I picked up some numbers. Maybe we'll just go through these numbers and see are there any interesting patterns or interesting phenomenon that we may want to explain with a model, or try and do something with this data. So that's it. So let's get started there. First thing I did was I did average runs by over. Okay, so I said what is the average runs in the first over, second over, etc. And you observe this very interesting pattern, right? 6, 7 and 8 sort of, right? So by the third over or the fourth over, it is really stabilized, and the fourth and fifth over and sixth over, and it's steadily increasing, diminishing returns. Okay, about 8.3 is the average runs by over. So it's quite expected. People start slow and then pick up and then accelerate as they go along. And standard deviation of runs by over, you want to look at how the spread is. It's not too bad. Its spread also seems to have stabilized to around 4.5, etc. And you might have studied in stats 1 what these numbers mean, what average means, what standard deviation means, etc. Okay, so another interesting thing is average runs in over 6. Right, over 6 is sort of like the best over in the power play, as at least as indicated by the average. So maybe you want to look at average runs in over 6 by the team. Okay, and then we can conclude which are the better teams, which are the not so good teams, or all the teams roughly okay, or is there some teams just so terrible, etc. And then there are interesting stories that come out, So many of you know that the Delhi Daredevils became the Delhi Capitals, I don't know, a couple of years ago. And look at the story there. The Delhi Daredevils had an average of 7.48 runs in the 6th over, and the Delhi Capitals have 8.94. Okay, so look at the big leaps, or something happened between Delhi Daredevils and Delhi Capitals. You can imagine what would have happened. And then you can see the good teams, Sunrisers, CSK, they are at the top of the average, and the poorer teams slightly lower, but you can see the spread is not so wide, it's between 7.8 and 8.9, so 7.4 and 8.9. So teams are okay, balanced in some sense, but there is a difference, and the difference comes out in small terms, and so you have to pay attention to small changes in the statistics, and that can make a difference, right? So it's important because these are all roughly equal teams, so you have to look for what is it that can distinguish in a small way, and maybe the better teams score more runs in the 6th over on average, right? So that is something we can look at. Okay. What about wickets in over 5? I was just showing you in quite a few innings there were no wickets, and several of them 1 wicket, and 30 innings there were 2 wickets. And I also I think I showed you this, the runs in over 6 by wickets in over 5, average runs. You can see that there's a big drop from 8.77 when no wickets fell in over 5, and 6.7 when 1 wicket fell. And okay, the 2 wickets, we don't really have too much data, right? So just 30 innings, it's not enough to make any meaningful inference from that. Anyway, we'll see all this later on, but that average ends up being 7.6. Okay, so just an example. I mean, this is in the IPL power play data, so we did some things that are relevant. And any other data you want to handle, you should do something like this, right? So look at part of the data. If you cannot look at all of them, look at part of them, and then ask these kind of interesting, simple, descriptive questions, and try and see if there is something here which is interesting. And this is always something that you have to learn, and it's not too hard to do, right? So you can do it using this little explore tab and at least see some basics in it. Okay, so we've seen that for the IPL data. And what are we going to do with this IPL data? Okay, so we will, as you know, in the first part of the week 0 lecture, I told you what we will study in this course. We'll basically study probability and statistics. That will be the main thing that we study. But I will keep this IPL power play data as sort of a running example to do illustrations and show you how one may use the theory we learn in probability and statistics to the IPL data, and see what happens when we do that. We won't do any sophisticated thing, but just simple-minded things, and ask whether there are reasonable probabilistic models for the IPL data, whether inferences that we draw from them are are they reasonable in some way, is it useful in some way, etc., etc. Okay, so that is something that we will try to do. So like I said, when we study probability, when we study statistics, we will use the power play data and come up with ways of applying what we study to that data and see what happens, right? So it's something interesting that we will try. Okay. All right. So let me leave it at this. It's probably a little bit vague right now. So maybe when I give you some examples, you will see how interesting, whether it's interesting or not. Okay, you can conclude for yourself. Okay, so let me end the second lecture of week 0 with another activity. Okay, so you saw one example of how I was able to get some data, do some small work with it, and then get it into a spreadsheet, and then do some descriptive statistics on that and say something meaningful about the patterns in the data. Okay, I want you to do in activity 2 something similar with any other data. Okay, don't pull cricket data. I know you don't just take data from another cricket tournament and do the same thing. Okay, maybe other data. There's lots of other data sources. This will also give you a way of running around and looking for sources. Don't go to try to avoid. I mean, I'll only say try to avoid, because you may not be able to avoid. Try to avoid these sites like Kaggle and all these, which already give you curated data, right? So that data that they have picked up and put into a good format for you to use. Okay, I want you to have the experience of looking for some data and then seeing whatever format it may be in, and then putting it into a spreadsheet in some way. Is that meaningful? So I don't want you to pick up, like, thousands of rows and hundreds of columns. Just at least, but do something slightly non-trivial. Go for 100 rows and 5 columns at least, right? So around that ballpark number. See if you can identify a situation. It could be something as simple as your neighborhood grocery store, right? So you have a grocery store and you're friends with the store owner, and maybe you want him to give you some data about how many people buy what product or something like that. What is the cost of the product, his inventory, who knows. It could be something as simple as that, right? So it may not even be anything very grand or big, or you don't have to search in the internet for it. You can go out and pick up something and see if there is any pattern or some interesting thing in the data that you observe. So this is again an activity. It's a graded activity, like I said. It's graded for the bonus marks that you may get, and there will be a subjective activity assignment based on this, and you'll have to put it up in your portfolio web page, right? So whatever data you collect into a Google Sheet, you put a link in that. You remember the statistics 2 page that we did for the portfolio. Below that there will be a section. In that section you put a link and then describe what data you got. Okay, so you can add text also. So you describe in that text what is the data you got and how you got it. Okay, once again, this is bonus. If you don't want the bonus, you don't have to do it, but I hope you do it, because this is something that will be very, very useful for you. Okay, thank you very much. With that, we conclude week 0 of this course, and I look forward to taking you on this interesting journey through the rest of the weeks. Thank you very much.